Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today we have the following problem from the test for high school students who went to college in 2003. The following is an arithmetic progression having 31 terms in which the first term is a-15d and the common difference is d. So the sequence starts from a-15d, ... and in the middle there must exist a-d, then a plus d, and so on. And for the last term, which is 31st term of the sequence, will be a plus 15d. Let sigma be the standard deviation of the values of the above terms. Find the value of sigma over d up to 2 decimal places. Here the common difference d is positive, and we will use this approximate value for square root of 5. Alright, let's get on to it. First, you have to find the arithmetic mean, which we will denote as mu. It is given by sum of all terms divided by number of terms, which is 31. And you can easily notice that all of d terms get cancelled out due to the symmetry of the expression. So we are only left with bunch of a's, 31 a's to be exact. So we have 31a divided by 31, which is a. So this is the mean, and now the standard deviation. First, we have to calculate the variance, which is simply the square of the standard deviation. There are two famous ways to calculate the variance. The first method is using the very definition of the variance, which is the mean of the squared deviation from the mean mu. That is, you calculate the deviation from mean mu for each variable x1, x2, ... xn, square those deviations, then find the mean of those squared deviations. The second method is using the fact that this expression can be rearranged into the mean of squares minus the mean squared, which can be easily shown using the definition of the arithmetic mean. In many cases, the second method turns out to be the simpler method, but for this particular problem, the first method using the definition of the variance is actually simpler. So let's apply this method. So in the numerator, first we must subtract the mean, which is a, from every term of the arithmetic sequence, and then we have to square each deviation, and we divide by the number of terms, which is 31. Notice that this time all a terms get cancelled out. So we have minus 15d squared plus ... plus minus d squared plus 0 squared plus d squared plus ... plus 15d squared divided by 31. So taking out d squared, we have 2 times 1 squared plus 2 squared plus ... plus 15 squared divided by 31. Using the sum of squares of natural numbers formula, which is n plus 1, 2n plus 1 divided by 6, first we have 2d squared divided by 31 times the formula with n equals 15. So 15 times 16 times 31 divided by 6. So 31, and this 6 becomes 3, which can be cancelled, and this 15 becomes 5. And let's write it as 16 times 5 times d squared, because it makes taking the square root process easier. By taking the square root, the standard deviation sigma is given as 4 square root of 5d. You know, because it is given that d is positive. So this is the exact value of sigma, and the problem wants you to calculate the approximate value of sigma over d up to 2 decimal places using this approximate value of square root of 5. So we have sigma over d equals 4 square root of 5, which is approximately equal to 4 times 2.24, which is 8.96. And that's all for today's video. Thank you for watching, and I will see you in another video.